Hey guys, and welcome to week 4. We are in the middle of a build. I'm at not my normal location, but we still had a good showing here today, even though it's Mother's Day, and I appreciate everybody showing up. So last thing we did was the OpAmp circuit. Got some testing done on that, some bodging on the backside, and some other stuff. But we're gonna talk through some of the other builds. So since the last one, we talked a little bit about the power stuff last time. We can talk a little bit more about that. And then we talk about relay and the OpAmp circuit. So, how is everybody doing? Wes, why don't we start with you? We'll go right to left.
Things are going well. It's been a lot of work just, double checking everything and putting it in. But so far, I think been lucky with things sort of working out of the gate, and little board cleanup and tweaking of solder connections needed here or there, but generally pretty good.
All right. Pedro, how about you?
Yeah, it's moving along. I just finished putting in the OpAmp.
Okay.
It's challenging, but it's rewarding too. Yeah, nice and slimy. I haven't tested it yet. Didn't have the time, but it's okay.
Okay. How's the pace? How's the pacing?
Fine. It's you can keep up.
Okay. Good.
Not too slow and not too fast. It's a good pace.
Good. Margaret, how about you?
I'm behind by about a week, and but I'm learning a lot, and I'm what I ended up doing was kind of mucking up the first board and now moving on to the second and using a lot of the different techniques approach the forum have. So it's coming along. So while I'm at risk of falling behind, and I'm just finishing up the additional power supply, it's coming along much better the last couple of days than it has the whole time. And you and the other folks have been amazingly helpful in getting me to do that. So I'm really quite happy.
Okay, good. Yeah, I saw you had talked about a little bit about some regulator issues, but then I think you might have figured that out.
Yeah, I have a couple of questions. I'll wait until you're at the Q&A, but one of the things that I don't know, maybe it's because I'm fairly new to this, but I was going to make, one thing I was going to make was a suggestion about perhaps having some kind of testing checklist. So, for example, when you hold up the schematic, it goes by so fast, and I'm thinking, okay, well, oh, right, now stare the schematic. Exactly. You wouldn't believe when Nathan was saying he was like stopping on it, because I've been doing that too. I have no idea how he's been doing that, but you go by so fast. But I was thinking of proposing that when you're getting to a testing thing, you have a check this net or sub-circuit. Did you get this value? Did you get that value? Check the voltage, check the continuity here, check the resistance here, whatever the check is. And then we can check those off to make sure we're on the same page. Now, some of the guys don't seem to need this at all because they're fairly advanced, but I think it would just help from a debugging perspective to go through this checklist, because I try very hard to then go back and test everything.
Okay, yeah, that's good. That's good. Josh, how about you? How's it going for you? Wait, you're still muted. I don't know if anyone else can hear him. No? Yeah, nothing. All right, you figure that out. Gail, you go next.
Well, things are going pretty good, actually. I haven't got the OpAmp in yet, but I've got the OpAmp in, but not all the rest of the parts and stuff. And I can't really test anything more except with my DMM, because my X Mini Lab seems to have bit the dust.
Oh no.
So, yeah, I think maybe it never really worked right to begin with, because it was fussy. I blamed my power supply. Every time I plugged it in, it was like, sometimes it would come on, sometimes it wouldn't. So I jiggle things, and finally it just doesn't come on at all now. So I don't know what to do.
You could try touching up the solder connections on the USB, or you could try bod
I
wire.
tried several different USB
You did? Okay.
wires, and
Okay.
things,
Well,
and
we
nothing
can talk a
works.
little
So.
bit more about that afterwards. But yeah,
Yeah,
that
yeah,
is.
sure. So
I
I'm
mean,
frustrated about that because it's the coolest thing. I really loved it. But
yeah. And it's frustrating too, right? Once you get used to having oscilloscope type of instrument, it's like, well, how did I live without this kind of thing, right? I mean, I need to see
yeah, yeah,
signals
yeah,
now. So how do I do this? And then it's kind of going back to just the DC side of things
yeah.
right there. So,
But things are actually going real well right now. Things are working and all that. It might. I agree with Margaret. It would be nice to have like a troubleshooting video or something on how to troubleshoot. I had one problem with the FE circuit, and uh, what happened was I had this tiniest little bridge, solder bridge, from one of my resistors to a nearby via, and
oh,
it just, yeah, and then it was right next to it, and it was just the tiniest little bridge, and it took me a while to find it, but fixed the thing.
okay, that's good. And it didn't
So
break anything in the process.
apparently not.
Okay. Cool. Josh, are you back to the land of the talking?
I don't know. You tell me.
Yes.
uh, yeah, everything's going good with the board. I don't have the testing done on the OpAmp section. I'm working on that today, but I am getting on my fixed regulator output a little bit higher of a voltage. But my supply is spitting out about 14.5 volts, so versus the 12 volt that everyone else is getting.
Yeah. It
So
actually shouldn't matter. That's interesting because so the only reason it matters is if it goes below, and the whole reason is that is because some of the stuff like the pass transistor and the internal resistor in there that is doing, or it doesn't have, sorry, no internal, but just the pass transistor basically burns off power as it goes through because it has some innate resistance. So it really should only be if it goes below 12 volts. If you're trying to get 10 output, that it should be an issue.
mhm.
So that's interesting though. Gail, was that you we were talking to about the wrong resistor value?
I had the wrong resistor value. I ordered
Yeah.
a 715 kilo ohm instead of a 715 ohm.
Yeah, that was an interesting behavior because it was effectively like the 715 was basically like an open. So what you might have is that your 715 ohm resistor could just be not soldered properly. It actually still outputs a decent drop, right? So it actually still burns some power off, but it doesn't actually regulate. So what was happening is Gail was having 12 volts in, and it basically burned off some power. But when the 12 volts started to droop, the output couldn't go any higher anymore. But in fact, it wasn't regulated the entire time.
Mhm.
So that could be an interesting thing to check there. Um, but yeah, I mean, there's always a lot of stuff like that. Are you able to get all the whole range and everything?
Yes.
Oh, okay.
Yeah, with the adjustable power supply, that all works out just fine.
Oh, I'm sorry. So you're saying for the fixed power supply?
Yeah, just for the fixed.
Oh,
So
okay.
instead of 10, I'm getting 12, so it's still dropping about 2 volts. Just like yours was going from 12 to 10,
Yeah.
mine is going from 14 to 12. So I didn't know if I needed to play with those resistor values.
Yeah, I would definitely double check that. I mean, usually that's going to be your first place to look.
Yeah.
If
Yeah.
you want to, you could solder in. I mean, you could always solder in a variable resistor into there, right? If you have an extra 5K, bodge wire that into to the 3K spot, and then just play around and see if it actually is regulating properly for different values. That's the problem there, is that you can't see that variety of ranges. So
Yeah. Yeah, I'll post the results on my build log.
okay,
So,
great.
but yeah, other than that, I've been going through all my different meters, and it's really interesting looking at how different meters give you different values. So,
Yeah,
been dealing.
like different DMMs, you mean?
Yeah. So I have a Fluke 16, and I was getting, when I was measuring the contact resistance of the relay section, I was getting, like 0.1 ohm resistance on that one, and then I had a higher accuracy meter that I was getting, closer to the 3 ohm that you were getting
Interesting.
on that contact resistance. So,
Yeah,
yeah.
that's an interesting look too, because of how, if you look at how that's built into DMM, really those actually have current source outputs, and usually that's what affects a lot of it, is how strong the current source can actually, how much current it can output. What is its output impedance? So if it has a higher output impedance, it actually can't drive such a low low resistance type of thing, right? So there's some meters that are better at driving lower resistances in the first place.
Mhm.
So that is interesting. Then.
Yeah, and the auto function of multimeters also is a different impedance than if you manually put it into the range that you're looking at, right?
Right. Yeah, that actually does fit the same. That fits the same behavior actually, because with the autos, they often have self-ranging current sources as well as self-ranging voltage inputs. So
Right.
yeah, that is interesting behavior. If you document that, I'd be really interested in seeing that.
Yeah.
Cool.
Other than that, Margaret, I reiterate what Margaret said about it would be really nice to have like a troubleshooting checklist, or not a troubleshooting checklist, but like a build, like test checklist.
Yeah, like this point should be 1.25
Yeah.
volts. This point should be,
Yeah.
yeah, it's like a sanity check based on that.
Yeah.
Yeah, that's good. And really that's what test points are there for, but yeah, you're right. If we don't list out the voltages, why even have them then? So that is
Right.
a very good point.
The other thing too is there's continuity testing, as you know, voltage testing, and some other ones. And at each point, you're using a different one. And for example, you might say, okay, here's the power source. Check. Use the AC coupler. Check to make sure about the AC noise. What did you get? It might be too high. That sort of thing, so that we can get a good feel for not only which tests, but which instruments, what logically we should do at each point in a PCB.
Right. Yeah, you want to make that connection for the next time when you see an issue. You're like, oh, I should have the AC coupled measurement for it on my
Right.
yeah, that makes sense. Okay. Yeah, that's that's my fault for when you've done it for a while. I kind of forget how it is getting started. So that's good. You guys are reminding me of that stuff.
I don't think it's a fault at all. I just think it's something that it just comes up. Your videos are terrific at going through it, so we actually have in some ways that information. I'm just saying I'm lazy so that I can be lazier. That's all. Not that you don't give the information already.
Okay. Cool. So what about the OpAmp circuit? Some of you guys have tested it, some of you haven't. How about soldering the SOIC? How's that been? Good.
Yeah, so I just ended up. Yeah, so I ended up just putting a lot of solder on it, and then using some solder wick to get off the excess, and touching it after that, and it turned out really good, I think.
Yeah, I've seen some people do that before. I think that works with SOIC, probably less so with the SSOP. That'll be a little bit more difficult, but yeah, the SOICs, that is, I've seen that before.
Yeah, your technique of taking the soldering iron chip and drawing it along the individual feet there, that really helped me.
Okay.
That worked.
Cool.
I put a blob of solder on the iron and then drag it as you did it on the video. I haven't tested it, but it looks okay.
Yeah. So that's going to be. So we keep inching closer to the SSOP part, and I know there's a lot of build-up for this. But interesting with drag soldering, right? What you do is basically you put down your part, and it's got a ton of flux on the pads, and then you put basically a blob of solder on the tip of your iron. And you basically drag it across the pins, and the same kind of thing happens. Basically, enough solder kind of gets pulled off that blob, and you kind of as you drag it across. You hope it doesn't bridge because of the solder mask, because of the flux that you have on there. So, oh, that's exciting. I'm excited about that. I guess, what kind of questions do you guys have?
I did want to comment on what Josh was seeing with the regulators, and I think David and I were talking on IRC a couple days ago, and the data sheets for the regulators specify a minimum load for the regulation. So I was getting some weird results from the regulator until I attached a load, and then it came into the range I was expecting for the resistors. So that might be a trap if you're trying to measure it without a load on it.
That's a good point. Yeah, especially if you are looking. Josh, are you looking at that with the DMM?
Yes.
Okay. Yeah, that does make sense then, because you could be, basically it could be rectifying an AC oscillation. right? And then if that's the case, then that could make it look like a higher value than it actually is. That's
Okay.
a really good point. Yeah, and minimum load is the same kind of thing we ran into with the adjustable regulator as well. What we could have done there, we could have switched our divider resistors to lower values so that actually actually creates a load. We could solder in, a 100, 200 ohm resistor, so it's just burning power, right? Because was it 10 milliamps, Wes? Is that right?
Yeah, that's right.
Yeah. So that is interesting. I mean, I don't know. I haven't actually tried the op-amp yet when it's not on bypass. So I don't know if you guys, if the ones who have tested it, if you've tried it with the regulator.
I tried it and I noticed that the outputs I get are a lot cleaner. My power supply is noisy, and using the regulated FE outputs, it actually cleans up the outputs a little bit.
Okay. Yeah. Well, that is the expected behavior. If you look at the whole reason we did this in the first place is for something called power supply rejection ratio. And what that basically is, if you look at the internals of a regulator, kind of like our current source looks like, right? It's like there's a feedback element, and then there's an op amp, and then it drives a FET, right? And it tells it if there's current going through, if there's enough current going through, if there's not enough current going through, then it drives it higher, right? And what it does is basically, based on the control system in there, that OpAmp circuit effectively and the pass transistor, that creates kind of like a double check on the circuit, right? We want some kind of smooth output, and it's going to do whatever it has. The op-amp's going to do whatever it has to do by turning that FET off to try and pinch off the noise through that FET, and that's really the whole reason that's in there. Now that works better for low frequencies than high frequencies. The high frequency stuff just kind of gets through there, but it's still it can definitely clean up some stuff. That's good to know that did help there. How noisy is your supply normally? Is it like an older supply, or did you buy one?
No, it's an older supply, and I have it sort of hacked. I attached a couple PC fans to it to meet the minimum load requirement to get it to turn on.
Okay.
But I don't see some of the Sawtooth kinds of signals coming from it that you have seen, and I think a couple others have posted. So I think it's internally implemented differently than maybe some of the newer supplies.
The ATX supply or the
Yeah, the ATX supply.
Oh, well, those sawtooths are coming from the linear regulators, from having minimum load on the linear regulators.
Okay. Yeah, so I haven't really seen that, so I don't know exactly what's going on there.
Okay. Well, it is interesting because I've seen some other people have posted about that in the build logs as well, about the noisier supplies, and it's kind of just amazing to see how that's changed. I mean, like mine is. That's what I was so surprised about when I bought that thing, was how quiet it was, and that's why I think this is actually a viable thing going forward. So maybe in the future we'll be like, don't use old ones. Like 20.
I have a nunchuck question. When you say high frequency versus low frequency, what frequencies are you talking about?
For the rejection ratio stuff, you mean?
Well, I look up Wikipedia and they say a high frequency is like 3 megahertz and above.
Yeah.
And so I looked at my AC noise signal, and it was like 2.5K, and my low frequency, this was with the pH, was about 0.4, it was very small, 2 hertz versus 2.5K hertz. So that would all be considered low frequency.
Right.
But the filtering, I put in a low pass filter to get out this quote unquote high frequency, but it's only 2.5K hertz. So what is meant by high and low frequency?
Well, it's always relative because
relative. Okay, that's probably just the point.
Right. I mean, it's always dependent on the situation. So like your pH situation, right? Your normal signal is 1 hertz or so, right? And that's the normal signal. So anything above, I would do it more by orders of magnitude, right? So 2 or 3 orders of magnitude above what your frequency is, that's high frequency, at least in my opinion. So your 1 hertz, normally 1,000 hertz and above is high frequency, because that's going to take 60 dB off your curve in order to actually start filtering it out properly.
Good. Yeah, that makes a lot of sense. Thank you.
So for another example of that is you talk to a ham radio operator. and or an RF person, right? An RF person, they don't consider high frequency until it's like gigahertz. It's like, really? I mean,
That's what I was putting some questions on the Ask Electronics subreddit, and the guy goes, all your stuff is in low frequency, and I kept saying, well, this is my high frequency, and this is my low frequency. So then it got me thinking, well, okay, he's speaking a different language than I am, or at least these different terms. So
yeah, usually it's within like subgroups that you have different people are saying high frequency, low frequency, but it's always relative.
okay, thank you. I have a question. Again, I'm behind, so I apologize. When you're doing the adjustable power supply, there were four 1K resistors, which I don't think you talked about, but they're on the schematic. R25, R23, R22, R25 to R22 1K. I don't remember them being on a video. They're in the schematic, and they didn't seem to be used by you during that part of the session. Did I miss something?
No, we did not so those are the quote unquote monitor signals that are going to be going back to the Arduino. So remember, the Arduino has 5-volt A to Ds, right? So 8-bit 5-volt A to Ds basically. And so this actually, someone pointed this out. This is actually upside down. These these dividers are upside down. Was that Pedro? I see him nodding his head.
I've been checking and I'm getting wrong voltages and then they're upside down. But
so those are upside down. So,
I didn't look at them. It wasn't me who pointed that out. I checked it.
You empirically checked it. That's good.
Yeah.
Yeah, it still happens. However many years on, guys, with electronics, you're still gonna do it. But the point of that is that so the V plus adjust and V minus adjust can go plus or minus 10 volts output. We wanted to divide that by 4.
Oh, right.
Is that right? 4? Yeah. And so then that will be a 2.5 volt reference signal going back to the Arduino.
So, in order just to do the test where you're doing with the potentiometers, you do not need anything on the left-hand side, correct? That's for the fix.
Can you say that one more time?
In other words, if I finish all the soldering on the adjustable power supply, all the things on the right,
yeah.
right? Probably those guys. Then I can try without doing it on the left. Correct?
Okay. So you're just kind of soldering. You're not following along the videos. Is that the idea?
So I am. You know the ones on the left. There's two. There's basically on that schematic, power adjustment monitor schematic. On the left-hand side, where there's like resistors 53 through 55, 52 to 55, Charlie 24, Charlie 25 on the capacitor.
Okay.
That left-hand side.
The left-hand side, you're saying C24 and C25? I'm having a hard time hearing you, Margaret.
Okay, the left-hand side has 10 volt output, 10 and the right-hand side has the Arduino's output.
And also the V plus adjust and V minus adjust, yeah.
Yeah, okay. The left, if I just do the stuff that has, to the right, that, where it stops with the plus 12 volts and minus 12 volts, that, if I just do that, then the potentiometers would work, correct?
Yes, that is the right side of the schematic is the adjustable regulators, the plus and minus.
And the left is the fix?
That's right. Those are going to the OpAmp.
Yes, thank you. I'm sorry if I was confusing on that. All right. I think that's it. Thank you.
Okay.
So I apologize. That's where I am on this.
Interestingly, the V minus adjust monitor, that is probably not going to work now that I look at it. I mean, obviously, we haven't done that yet, but that is something that is going to be interesting because that's all referenced to ground there and going to the that might be an interesting problem to solve. We might be able to solve it actually, but we'll see. Yeah, we'll see about that.
Why do you say it's not going to work?
So okay, so that's reference. So the V minus adjust monitor is if the resistors were right, reference to ground power there, right? Those are all referenced off that ground power. That would go from 0, well, probably not, a little bit more than 0, to minus 2.5 volts. And then that minus 2.5 volts would actually be going over to the Arduino. The Arduino actually is only a positive, let me measure positive signals. So unless we do something for that, it probably will not work. So that'll be an interesting thing. We might be able to do actually something that Margaret's been working on in her side project. That it's basically a biasing circuit that allows you to bias up, but it would take extra parts. So I'm not sure we'll be able to do it. So we'll see. That's fine. We'll leave that for later though. And that was an optional feature in the first place.
One last question. At one point I got the board smoking, but you said that heat sinks, you're going to have to take them out. I don't have to put them in at all, do I, at this point, to do any of the testing? Nothing will get too hot, the FETs or anything.
Right. Nothing. Yeah. Nothing. It shouldn't be necessary at all, actually.
Okay. That's good. Thank you.
Can we have everybody put yourselves on mute unless you're talking to? We had some rustling noise and some other noises, so keep making the screen jump around. It's making me a little seasick. That way I can know who has a question as well. So, who has a question? You can unmute yourself and start talking.
Still on the power section.
Okay.
The diodes. We haven't populated them.
Correct.
Yet. Should we? Shouldn't we? It's the short circuit protection, correct?
Yeah, that's the protection. So basically, do you understand how those work, or is that what you're asking?
I think I understand how those work, but I'm not actually 100% sure.
Okay. So if we look at the adjustable regulator on the right side, right? So the top, so U11, right? The top right one, the V plus adjust output. If you have that diode there, and say you're outputting the max it can do 10 volt output, right? And you're outputting that into another circuit, right? And another circuit, at first, the other circuit is it's accepting power fine, 10 volts, it's using the 10 volts properly, but then because of something that happens in that circuit, basically the voltage starts rising. So maybe because it has an inductor and it gets shut off quickly and it doesn't have a kickback diode, right? What would happen there is if you had a voltage spike on V plus adjust right there, right? Basically, you'd have 12 volts at the input, you'd have 12 volts at the output, or sorry, maybe let's say 20 volts at the output. For some reason, it spikes up to 20 volts. So you'd have 12 volts at the input, 12 volts at the output. Basically, the internals of that circuit would not be able to handle that. And the idea is now the right side is higher than the left side, right? And you see on D6, the cathode is off to the left. So if you have 20 volts on the right side of D6 and 12 volts on the left side of D6, that's going to turn on and start conducting, and it's going to conduct and try and push current back the other way until the voltage drops, right? And so basically, it's going to help with spikes. It's going to help with overages. I mean, if it's a huge voltage surge where it has 20 volts there for an extended period of time, and that D6 turns on for an extended period of time, it's going to burn up. But that's better than burning up a regulator, even just from the perspective of, well, now you don't have to try and rip the regulator out. You can just replace the diode.
So it's more on the testing. It's not exactly necessary for now, ready for later when the finished product.
Right. As we start using it more, that will make more sense for sure.
Okay, got it. Thank you.
You know, that was another. Talking about using the product as well. We were talking about this, I believe, in the IRC a little bit. Talking about the relay circuit, right? So before we started, Wes was mentioning how he's doing testing on circuit and testing on the opto and stuff like that. And interestingly, once we get the current output working, we'll actually be able to use that to test the characteristics of the opto and of of the NPN that's driving the relay to turn on. And so there actually are not optimized values for the relay circuit, but we'll actually be able to circle back once this stuff's working and test those components with other parts of the board. I thought that was pretty cool. Wes, do you want to talk about that a little more, what you found there?
Yeah, so first looking at your simulation, I noticed that there were some really high currents going through into the base of the NPN, and also really just was observing some unusual voltage drops across sort of the transistor side of that opto. And I knew that the way that we had things set up on the Arduino side, it was like about 20 milliamps going through that IR LED. And so yeah, just trying to figure out what the currents were and the voltage drops. Sort of realized that there was a whole lot of current going through the relay side of that opto that was probably more than we really wanted to, and definitely more than we wanted going into the base of the NPN.
Right. Yeah, I think extended behavior. So it works, right? That was a joyous point, but that's a very different behavior than works well or works long term, and that's really what it seemed like you were getting at. And that's good, and we'll be able to look back and optimize that kind of stuff.
Yeah, and I really saw. I think that that opto is not just an on-off switch. It sort of has some curves there, and as the current goes up, I think we get into one of the non-linear regions where it's not in saturation, and I was seeing some variable resistance there too that would ultimately throw off some of the stuff happening, in the other areas of that circuit. Thankfully, it's really simple, so you can sort of measure the voltages across 2 or 3 components and get the full picture.
Right. Yeah. Yeah. You imagine it in like a more complex circuit, it could be more problematic because you wouldn't necessarily be able to point to that and say, oh, this voltage is definitely affecting this other stuff. So yeah, that's a good point. Yeah, and the other thing that's interesting with optos too is that they actually do degrade over time. So as they start to age, as the internals of the optos start to degrade a little bit, you can have less clarity in there. The LED can output, the IR LED might output less current, and you can actually see difference in behavior there. So that's another thing to look at over time and start. I'm not sure this is going to be like an heirloom product. I'm not going to be handing this down to my kids, but we want it to last a couple years at least, hopefully. And if it's going to blow up and stop working, we want it to be us that make it blow up and stop working, right?
That's right.
Important.
Yeah, after the smoke test, when I turn things on, I do the touch test to see if anything feels like it's a little too hot.
Yeah. Any spicy ones that came through? I didn't actually do that on camera at all.
No, nothing has burned me other than the soldering iron.
Yeah, good. That's what it's there for, right?
I have a question about the opto. What is the why do we have one? I mean, the relay is already separating out, providing a distance between the electronics and the whatever it is you're driving. What's the purpose of the opto?
So the real reason is for to separate out the 12 volt from the Arduino, which is on 5 volt. Because basically, if we think about just putting that, we could just drive an NPN directly, or a FET directly, and that would work. But basically, if there's any kind of short there, and we get 12 volts back onto the signal pin from the Arduino, then pop goes the weasel. Alternately, if the 20 millivolts or milliamps coming out of the Arduino was not enough to actually drive whatever we needed to turn on, I mean, really, this stuff should all work. With 20 milliamps coming out of the Arduino at 5 volts, right? There's even there's some logic level relays. You can get 5 volt relays where 5 volts, probably a little bit more than 20 milliamps though, but with 5 volts you can turn on the coil directly from some kind of 5 volt source, but that's more cost and it's less standard. So that's the reason not to do it.
So it would cost more if we try to switch the relay with 5 volts instead of the 12. So
Yeah, well, that's one
Those are,
reason. And then also protecting the Arduino. I mean, that's really the real reason. And
but
this kind of,
but if you use 5 volts, that's what the Arduino can handle anyway, right?
yeah. What else do you mean about that? You mean like the
Instead of driving with the 12 volts, just use 5 volts to trigger the relay.
right. So that would be a different type of relay, right? So that'd be a
Yeah.
less standard, more expensive relay,
Okay.
and it would probably actually require more than 20 milliamp. What I was trying to point out is that 5
Got it.
volt relays do exist, but they're more of a hassle.
Okay.
Yeah. I did notice actually, so thinking about 5 volts out of the Arduino as well, there was some stuff with, I forget what it was. Oh, it was actually in the X Mini Lab. That is a 3-3 digital input only. So we might have to play with that if we want to do digital input stuff. We might have to get some logic level converters or something like that. So that could be interesting as we start troubleshooting that. I saw that the other day. I was going through the data sheet again for the X Mini Lab. So that is a downside, but not one that's insurmountable. So. So what other questions?
I have a question. I've been admiring Blair's Bling with it, and his videos. They've been awesome. And he's using a hot air reflow, which is attached to his. What is your opinion or others' opinions on using a hot air reflow on the system where he's got that, I don't know, how do you pronounce it? IUEOEO, a soldering station. Yeah, OEO. It has the hot air reflow on it. Are hot air reflows a must-have for your desk, or because I'm basically drafting at things that would give me a handicap, like a golfer gets when they get handicaps.
I love hot air reflow guns. That's the only way I usually solder, but it was a cost thing. So, and really, I mean, it's good to learn with a soldering iron first. Really, it is. I mean, there's different levels, right? So just using a soldering iron, right, that's going to be difficult but doable. Hot air reflow pencil is going to be, for certain things when you're removing off the board, it's almost unnecessary, like multi-pin type stuff. But using it for assembly is nice as well. You get nice reflow, nice fillets on all of the solder joints and stuff like that. And then the next step up from that would be like buying a toaster oven and doing that. So maybe in future contextual electronics sessions we can go into toaster ovens or something like that. But
do you have a hot air reflow you'd recommend?
A what? Like a reflow pen?
Yeah.
That AOU is actually, it's pretty good. I don't have one. I used to have a what's the other one? I can't remember the name of it. I'm sorry. It wasn't mine. I had it at work, so.
Because I didn't, it's a different attachment than the ones that come with the one that you recommended. I didn't think you could switch to the one that has the hot air reflow on it.
Yeah, it's a totally different piece of equipment. It's about 2 to 3 times the price of what we got. So that's the reason I didn't do it. So the way a soldering iron works is actually just a transformer. So it's going from like 220 or 120 in the States rather, 120, and then it's basically just transforming that to like a lower voltage, like 24 volts or so, and then pushing that out to a heating element, and that's in the tip of your soldering iron. In a hot air gun, in a hot air reflow pencil, it's doing somewhat the same thing, except now it's a larger element, and it's heating that up and then blowing air across it. So you actually do need a blower unit in order to blow air across that hot element. So
you'd be replacing the whole unit then?
Yeah, you'd have to buy something completely new if you wanted to do it.
Oh, all right.
It's just the same brand name. The AOUE is just a brand name. So.
I'm loving his videos.
Yeah.
Thank you. Well, I have another question then. With the AC noise, have you thought about doing a video or an instruction on creating an LT spice of the AC noise signal on a power supply?
I never liked the noise function in LT Spice. It just isn't. I don't like it. I mean, like, it exists there, but it exists for very advanced stuff. I don't think it would be beneficial for us.
Okay.
I could be wrong, but I don't think it. I think AC analysis of Spice is good because it shows you optimum behavior, but there's so much randomness that you have to try and get into there. It doesn't seem worthwhile to me right now.
So your point is okay, you can stimulate the system as it should almost perfectly behave,
Yeah.
but the variables, particularly noise that might come in a power source or things like that, or are left to actually breadboarding, prototyping, and using an oscilloscope.
Right.
Okay.
Yep.
That makes sense.
Life should always be the optimum, and yeah, real life should be everything else. You always should check it against real life.
Okay. Thank you.
What about other questions?
Yes. So speaking of real life, have you done any testing between your two boards, Chris, or anyone else? In particular for the OpAmp circuit, they're slightly different gains I'm seeing, and part of it, I went back and did some cleanup of the board, resoldering some connections, cleaning the flux off, but still seeing a little bit of difference there. So I'm just curious if that's something that you've seen or anyone else may have been seeing yet.
So
I went back and they all are like 1% resistors for the critical parts, and those look good.
0.1%?
Yes, 0.1%.
Okay.
The one thing that I did find that was a little surprising, and that I did some cleanup, is there was a couple kiloohms resistance across the jumpers when they weren't populated. So I think that was contributing to what I was seeing, but I'm just curious what others had seen.
A couple of kiloohms when they weren't populated. That is interesting.
And I think it was just either, I don't know that the resin is conductive, but so I took some solder wick and got a little bit of the solder off of those connectors, thinking that maybe I had made an unintentional connection on the top side of the board, or
Yeah.
I don't know. I was just curious.
Quantify how much is a little bit of gain difference? Like,
Well, it's in the probably less than 1%. Like in one case, with the unit, no jumpers in there with a 1 volt peak to peak, I was seeing around 32 milliamps peak to peak on one, and around 34 to 36 on the other.
okay, interesting.
And then with the 1,000 ohm RG resistor in place, I'm seeing, so again, about 1 volt peak to peak on the input. I'm seeing like 282 to 286. So 282 is on one board, 286 millivolts peak to peak on the other. So it's good, and playing around with some of the noise filtering features of my oscilloscope, that improved what that looks like a little bit, but
Yeah.
still something probably with board assembly that's going on there.
So 282 to 286, so that's like a 4 millivolt difference, right? Over 1,000 millivolts, so 0.04%. It's, yeah, I guess that is a little higher than I'd expect, but also so the other thing that can happen, right, is that even though we bought 0.1% accurate, is that you can see differences between, so if we look, hold this here for a second. So if we look, like these two resistors can be different from one another, and these two resistors can be different from one another, and they can also be out of sync here, right? So if you had, instead of having 200,000, 200,000, 4990, 4990, if you had 200,000 and 10, 199,990, like basically if they start skewing in different directions, right, it's plus or minus 0.1%, so there is possibilities that these start to go in different directions. So what we can do for that is we could start doing the step parameter in SPICE and actually start to look at how that actually changes the gain output, and it might actually end up changing, right? And so ultimately what would need to happen in any system, what you would do is that board to board, what you would do is you'd input a known good 1 volt, right? And then you would look at it on the input to the A to D, and you'd say, this is 1 volt at the input to the board. What does it look like on the A to D? The A to D says, well, no, that looks like 1.04 volts. And you say, no, no, that's 1 volt. And that's what calibration is, right? You have a known good source, and then you normalize it, and then you hope that over time and temperature, it doesn't shift around much. So, so what that points towards is we might, if all else fails, we might need to calibrate, or it might just be a stack-up issue where we'd have to buy better parts or whatever else. So that is something we can look at more.
All right, yeah, I'm curious as other people have some results to see what kinds of gains they're getting.
Yeah, right. What were you measuring on? You were measuring just on your DMM on the output?
I was using one of the 1052 Rigol scopes.
Okay. So you were measuring AC characteristic as well? Okay.
Yeah.
So another good test there might be to stop doing AC, to input just a known DC voltage. So we could do that by swinging the 3.3 from the output back and around, right? And then measuring that with a DMM, and then looking at that on the like on the, I guess we need to come up with names. The unconnected gain stage, right? The it's because it's not a gain of 1; it's a divide by 40, right? We learned that the hard way. But basically, doing that math, checking that all the way through on both boards, and then looking at that DC to see if it's an inability to like just maybe there's smaller differences that you can measure DC. That might be a good check as well. So
I think someone had commented on the forums of using our adjustable regulator. Even
works even better. Hey, what do you know?
Yeah.
Boards testing boards. Next thing, we'll have robots building robots. It's good. No, I like that. That's a good idea. Okay, so yeah, I'll make a note of that, and that might be a good test to do, especially comparing two of them.
All right, good.
What about other questions? Do you guys see my my Porto Lab thingy? That silliness. Yeah, Pedro likes it. All right.
Have you got something put together? I heard you talking about it.
So in the update yesterday, I did finally cut out some foam, and so if you look at last night's update, I didn't get any videos in because I was traveling and I was working on that thing. But yeah, it's kind of together, and I tried it out today, and it doesn't melt foam like when it's actually working when it's inside the case. So I think it's actually got me dreaming about, obviously I'm jumping ahead too much, but I'm already dreaming about an entire line of test instruments just running off a 5-volt ATX power supply, tying them together. We'll take over the world, after that, right? After test equipment runs off
all we
need,
need is some larger PTC thermistors, and we're good to go.
Yeah, that and everything else to work okay.
Speaking of the PTC thermistors, do you have any comments on why stacking them didn't work?
There was a couple theories about that. I haven't gone back to look at that anymore, but the most credible. So the reason it didn't probably work in the context of what we were using it as was actually because it wasn't that in the first place. So someone measured on the forum. I think they said there was like 3 ohms or so of drop on the inductors. Is that you that said that? Someone said that. I don't know.
No, someone else.
Yeah. So there is a DC resistance in every inductor. There is DC resistance, and so I actually haven't measured mine yet, but that actually does kind of line up with a drop that would always be there, right? So if we're pushing up at a 0.5 amp, a 3 ohms could start to be a pretty significant drop there. I mean, depending on what it actually is. So it's going to be there regardless. In terms of why it was still starting to pinch off, though, putting PTCs on top of one another, the heat could, even though the resistance is less, the heat could conduct through them. So I guess the short answer is no. I don't know why yet.
Chris, one of the other things that David and I noticed when chatting on the IRC is for the data sheets for those regulators, the VN minus V out minimum is 3 volts, actually.
Oh, really? I thought it was 2 volts.
Well, at least the ones that we were looking at, it's 3 volts. So to sort of be in spec for the regulators, I'm going to double check that. So that could be part of what you're observing as well.
Oh, just because it's getting, you mean because it's actually under load at that point, and then it starts to dip?
Yeah, under load, and it's 2 volts is sort of, you know, less than what that minimum
Right,
spec.
right. Yeah, that is a good point, actually, because of the how much it can. But I thought we saw, I'm trying to think back to this video as well, I thought we saw that the input voltage also drooped. So that wouldn't actually match that, right? So if we looked at if the input voltage droops down to 11, we were able to measure that difference as well. I mean, that's a good point. Like, definitely you should always check stuff under load because you start to see different drops and different characteristics, but I'm not sure that matched what we saw because I remember seeing 11 volts reference to ground at the input to the regulator.
Okay, that may be. I don't recall.
And I remember thinking 3 volts as well when we started, but then I thought the data sheets of the ones that we got actually were 2. So I think we're going to be on the edge no matter what, but it is a good question about whether it's the PTCs or whether it's the actual regulators dropping out. Any other questions?
Again, on the PTCs, when I saw the video, you stack them one on top of the other. The one on the bottom will heat up the one on top. Maybe side by side they would work better. They would have air on top to cool them down, not another hot one.
Or we put a Peltier in it.
Then you have an extremely cold one and a hot one on the top.
Yeah, someone else has suggested to actually wire them separately, kind of like wire them vertically so they're not touching as well. To be honest, I'm not too worried about it just because I think that in general we should, I guess it's interesting from a physics perspective, we should check that out, but ultimately what we're going to do is just buy the different one, right? So we're specing a higher current one.
I got them yesterday.
Oh, you did? Yeah, you try them out yet?
No, haven't soldered them yet.
All right, please do let us know on the build logs. That would be good to see.
Yeah. I'll do that.
I know.
If I can get them out.
Okay. Yeah.
I'll keep everyone apprised.
Okay. Good. How have the build logs been going? Has everybody been able to follow each other okay, and updating's going okay on there?
Yeah,
I think the build log has been a great innovation to the team. It's the most active. To me, it's almost as good as email. I have found that leaving comments on the forum is not very effective because as the forum passes, people don't read the forums because they're not in the daily update. But having the daily updates with the daily builds and the comments that people make in the daily builds has been extremely beneficial to me to see how other people are approaching the problem, since most people are more advanced in techniques than I am.
Huh. So you're saying that if you comment on the rest of the other half of the forum, it doesn't show up? You're saying?
Well, it's interesting. The group and the group one, and they're both groups, but the daily digest, the daily build, and the group questions or forums, they get a daily update, so more people are inclined to read it. The forums, I'll ask a question on a forum, say, three on one of the videos, and it's about 4 videos back from the most current one, and I won't get a reply, and my assumption is that there's a small probability that people are actually reading the older comments from forums from like 3 or 4 days ago.
I'm getting email updates on the forums, on the regular logs. Yeah.
Okay. Yeah, I am as well. So.
Yeah.
Well, Yeah, it must, again, just like the other thing, it must be me. I get the update for, I guess maybe I just didn't sign up for them, that's the problem. But, okay, so all three of you can get a daily update on activity.
Yeah, you
Right,
should.
but they're at the bottom. You know.
Yeah, right, exactly. So there are two separate sections basically. If you get the email that says daily digest of group activity, contextual electronics, you should see two different groups. So I'm looking at the one from May 8th, 3 days ago. I have the 2014 build logs. You can click on that. It'll take you to 24 different items. And then session 1B, spring 2014, which is where the blog is posted, and then that's where the other forums are that you mentioned, Margaret. So
Okay. Okay, just my misuse of it. But about the build logs are just terrific.
yeah, I'm really pleased with how everybody's updating that stuff. It's great. And I was looking through I uploaded those pictures last night to the blog, and I'm looking through it. I'm just like, wow, there's so many pictures on here now because everybody's uploading their own pictures. It's great. It's just great to see. So it's really nice.
Yeah, I have an appreciation for the videography that you do and be able to get the angles and the lighting because it's not easy
Ducks.
to get those conditions just right. So you're doing a pretty good job with that.
Well, thanks, man. There's actually a good. So John Janier, one of the guys that used to photograph for Adafruit, he has a guide about doing photography for electronics. So if you're interested, it's really pretty all inclusive. I mean, it's more about using lighting and actual backgrounds and stuff like that. But if you're interested in that kind of stuff, yeah, I mean the surfaces are not easy to get properly.
No, it's not. The shadows and all that stuff. So
Yeah.
I'll have to check that out.
Yeah. Well, any other questions?
I had one, but I can't remember it, so it'll wait.
Okay. Put in your build log. Things to ask at the next Hangout. Okay, so thank you everyone for showing up. I'm glad it worked out better this week. I'm sorry it was on Mother's Day, uh, um, but next week I will, do the same kind of thing, having a separate post. Hopefully that worked a little bit better in terms of trying to get the word out about it. So hopefully that was worthwhile or useful rather this time. All right, well, have a good week, and we will be building more, and I'm excited about it.
Thank you.
All right, thanks.
Thanks.
All right, guys. Yeah.
Uh,
Bye.